Chapter 7, Chemical Quantities, Section 7.1, the mole. Remember to, after this video, go and look at video problems 25 and 26. The mole is a huge deal. So the mole is what we use to count in chemistry. And all it is a word that represents a number. Which isn't weird at all. So we say a case, that's a word, represents 24 of whatever. A gross is 144 of whatever you're counting. 1 dozen we know is equal to 12. And so 1 mole we know is equal to 6.022 times 10 to the 23rd. Now what's important is what you're counting. Let me give you an example here. If I have a dozen elephants, right? So I got a dozen elephants. How many elephant legs do I have? Well, you know that you actually have 48 elephant legs, right? So here's why. The dozen is counting elephants. And we know, unless they are maimed, and I hope they're not, each elephant's going to have 4 legs. And so that's why there are 48 elephant legs, even though there's only a dozen elephants. So it's very important what you're counting. Now, particles is a very generic term, and if you don't know if it's a molecule or an ion or an atom, it's safe to just say particle, right? Because that's sort of a catch-all. Don't lean on it too heavy, but you know that's what you can do. So this number, 6.022 times 10 to the 23rd, that is Avogadro's number. So there's this man named Emilio Avogadro, very, very homely person. If you ever look him up, only look at it with one eye or you go blind. But he did a lot of work with equal volumes. He didn't necessarily perfect this number. It's just named after him. Okay, so 1 mole is 6.022 times 10 to the 23rd. That is a gigantic number. It is astronomically large. So, just here are some examples. You know, if we have 1 mole of aluminum, what are we counting? We are counting aluminum. What's that mean? That means that we have 6.022 times 10 to the 23rd atoms of aluminum. 1 mole of iron, that means we have that many atoms of iron. 1 mole of water, well now, water is a molecule. So that means that we have 6.022 times 10 to the 23rd molecules. No longer are we talking about atoms, now we're talking about molecules. Vitamin C is also a molecule. Sodium chloride now is an ionic compound. We call it a formula unit. I'm fine if you call it a molecule. I'm not going to kick you out of class. All right. So here is the idea of a mole, Avogadro's number. All right. And so what you need to know is, again, what you're counting. So a chemical formula, which a formula can either be a molecule, okay, or it can be a formula unit. And those are pretty much what we have. We can say a compound as well. Compound and molecule are sort of interchangeable. So the chemical formula actually indicates the number of atoms that make up that molecule. Okay, so here, for example, NH3 is made up of 1 atom of nitrogen and 3 atoms of hydrogen. Okay, that's if I have a molecule. Now, if I have a mole, then it's made up of 1 mole of nitrogen and 3 moles of hydrogen. Okay? So here, for instance, let's say I have a dozen NH3s. So here's NH3. There's 1. I'm gonna do a dozen here. Let's do this the easy way. Ooh, that's not what I want. Control Z. Alright, now. It's not letting me do it. There we go. Copy. Paste. The amount of time it took me to do that. Oh, what the world. Sorry, technical problems. You know what? Screw it. Let's just go on. So let's say a half dozen. Right? So if I have a half dozen NH3s, right? How many nitrogens do I have? Well, I have a half dozen nitrogens, right? 1, 2, 3, 4, 5, 6. That's a half a dozen. How many hydrogens do I have? I have 3 half dozens of hydrogen, right? So 1, 2, 3, 4, 5, 6, but then each one is 3, so that gives me 3 half dozens. Right? So sort of looking at the same idea with this chemical formula here. In the formula, if I'm talking about the molecule, I have 9 carbons, 8 hydrogens, and 4 oxygens. But if I'm talking about a mole of it, then I have 9 moles of carbon, 8 moles of hydrogen, 4 moles of oxygen. So it really depends on what you're talking about. Okay, and when you go to look at the video problem, that's going to help you out too. There are those stray ammonias. All right, that's it for this one.